Typically on an exam, you're given, some sort of table and you have to circle the non-zero terms in the energy principle. Okay, so let's take a look at this one. So we have this problem here, and it says that you apply your horizontal force, okay, F, to a block of mass m that is initially at rest. The block travels a distance d before it leaves your hand. Okay, it continues up a rough incline of an angle theta, traveling a distance h. Okay, travel distance L before coming to a rest at a height h above the horizontal floor. So here's my tip for approaching these problems, and these will work all the time. Okay, you want to draw a picture first. So if I'm looking at this, there's my incline. Well, there's my floor, and I have a block, right? I have a block, and it has a mass. Okay. Now it says that it says to me that you apply a horizontal force. So maybe you apply a force like this. Okay, so there's my force. You apply a horizontal force. Okay, and remember, it's initially at rest. You apply a force and it moves, and actually then moves up a plane of an incline at an angle theta. Okay, moves up an incline of an angle theta. Okay, and it stops at rest. So there's our picture. This is simply enough for us to visualize. So now it asks you, okay, well, we have the left side of the equation and the right side of the equation. Left side of the equation and the right side of the equation, okay? And so it might ask you, okay, well, circle the non-zero terms. Circle the non-zero terms, okay? So just look at the system for the block alone, okay? So we have all these options. We got to circle the non-zero terms, okay? So first thing I like to do is remember, and just remember this, the left side of the equation represents everything that's internal. The right side represents everything that is external, okay? And so when it asks for us to look at the block, okay, well, the first thing I like to do is circle my object. And so if I circle my object as only the block, well, what are my forces? Well, let's use the energy principle. We know the change in energy of the system is equal to Q plus the work external. Okay, now because my object is only one object, it's only the block. Remember, we cannot have we cannot have potential energy. We cannot have potential energy. We only have potential energy when there's two things. And so what are the Q and what are the work external? Well, if I look closely around my object, I could see that at some point my object was moving up, and at some point gravity was pulling down. Okay, so there's gravity pulling down. Okay, that's nice to know. So we know the work external, we're going to have gravity out there. Okay, now it's moving along a surface here, so we know that that's causing friction. So we know that our Q will be friction. So we know that there's some sort of friction here. So maybe we could just say this is mu sub K, kinetic friction. So those are the external things around my block. I see gravity, I see friction. Well, what else? Do you see anything? Well, again, what is external? And this is why it's very important to draw circles. Because if I define a block as my object, well, I know that there's some sort of force. Okay, that's the force that's external. And is it positive or negative? Well, the displacement is going to the right, the force is going to the right, and so that has to be positive. Okay, so remember, whenever there's one object, we usually represent our equation by saying the kinetic final is equal to kinetic initial plus work external, because there's no potential energy, and we also have Q out there. Okay, so now that we have this equation, we're just going to simplify everything. Okay, so kinetic final, well, let's explain something here. Let's look at the problem. It says that you initially start at rest. Okay, you initially starts at rest, and at some point, at some distance h above the floor, you actually come to rest. Okay, so with that being said, we know that kinetic final is zero because it stops. Okay, it ends at rest, and so there's no kinetic energy. Kinetic final is zero. Vice versa, kinetic energy is zero. Kinetic initial is zero because, again, we start at rest, and so we didn't start with any kinetic energy. We were at rest. Okay, so we know that the left side is now 0 because our kinetic final is 0. Okay, and so for the left side, we could circle this to be 0. So the left side is actually 0 in this case for the block. Now, what about the right side? We just talked about it. We just said Q is due to friction. So Q is due to the friction. Okay, and again, friction is always opposite of the motion, right? So we know friction is going to be negative. So we could say this is negative mu sub k mg cosine of theta L. Okay, and so we could circle our negative mu sub k mg cosine of theta L. That's on the right side for the block. Because again, friction is opposite, okay? And it's outside of force, so that's external. Now, what else do we have? We also have a positive force times the distance, okay? So our force times the distance would be positive, and we have to circle that's not 0 because it is external. You could see the force is positive, right? Because yeah, actually we're talking about the work here, yeah? So the force times the distance would be the work, okay? And you can see that we've done positive work externally, okay? The block is moving to the right, or displacement is to the right, or force is to the right. And so we gotta have positive Ft out there, okay? And so that's why we circle that also. Now, what else do we have? Well, remember at the top of the block, at the top of the incline, we have gravity that's pulling down. And at some point, the block was going up, gravity was pulling down. So gravity has to be negative because the work done by gravity is negative. We have the displacement going up, gravity is pulling down. They're opposite. And so this would be negative mgh. And so this is also something that we should circle. And so if I'm looking at this, we know that the left side is 0 because the change in kinetic energy, kinetic final is 0. It starts at rest, it ends at rest. Kinetic initial is 0. So we know left side is 0. And then we know the right side, we have the gravity that's pulling it down. It's opposite of the displacement, so that's negative. We also have kinetic friction, which we know is always negative, opposite of the force. And then we have the force times the distance, which is our hand, essentially. That's external to the block as the system. So it's very important to look at what is my system, okay? And so here comes the trick with this, okay? Here comes the trick with this. Once you have the equation for the just only one object, in this case, just only a block, the only thing we're going to do is just manipulate this equation to put anything internal or external. We don't change anything, okay? And let me show you. So now that we've had the equation for the block, what about the block plus the incline? Well, I'm going to redraw the picture. So I have the mass and there's some sort of force external. And then at some point I have some sort of incline with theta. And there's my block. Okay. And again, we have kinetic friction here. We could say this is mu sub k. Okay. Now it asks for the system as the block and plus the incline. So if I look at this of the block plus the incline, then I circle my block plus the incline. Okay. The block plus the incline. Now remember, my block is a part of my system, and so I could circle this also. Okay, so the block plus the incline. So if I'm looking at this, we already have the equation. We just got to figure out what is external, what is internal. Okay, and so if I'm looking at this, choosing the block plus the incline as my system, do you see that friction is actually inside now? It's inside my my system, and so that's why it's very important to draw and circle what your system is. And you can see now the incline is a part of the system, so friction is actually inside. So if I'm looking at it plus the block plus the incline, yeah, all I do is just add this over here. So this becomes plus mu sub k mg cosine of theta delta L. Okay, now what else is internal? What else is internal? Well, as you could see, pretty much nothing else. Friction comes in. We still have the force external. We still, because the block plus the incline, we still have the force of our hand that is external because that is not defined as part of our system. So that stays out there. And gravity as the earth is not defined as part of our system. And so the equation for the block plus the incline will just be Fd minus mg on the right, and friction becomes internal. And so if we look at the options, well, what has to do with friction? Okay, it's a change in thermal energy, right? Change in thermal energy. That's why when you rub your hands together, it gets hotter. That's friction, which it causes a change in thermal energy. And remember, we moved it over on the left side of the equation, which it becomes internal, so it's positive. So therefore, you could circle a delta E chemical, which is positive. So that would be the left side for the equation, the block plus the incline. Okay, now what about the right hand side? Well, we just sorted out. We just said because the force or hand is not a part of our system, that stays out there in the external end. And we also have negative mgh that stays out there on the external end. Okay, so as you could see, moving from the block plus the incline plus whatever, all I did was, once I found this equation, all I'm doing is manipulating, changing, switching sides to see which is internal, which is external. So last one says the block plus the incline plus u. Block plus incline plus u. Okay, so let's redraw the picture. So here's our mass, here's our force we've been applied. There is the incline of theta, and there's our mass, okay, at some point after. Now it says the block plus the incline plus u. So there's me, there's my hand. Okay, so now this becomes a part of my force. The block plus the incline plus me. So we're taking everything as a part of my force, and look what happens, okay? You could see that as a system, we still have friction that's inside. Now look. Because it's u, we now have the force times the distance as a system that will be inside. And so this becomes plus mu sub k mg cosine of theta L minus FD. Because we've got to bring the force over and we subtract it over, okay, inside to signify that now it's internal. So that'd be negative FG. And look, what's the only thing that we have pulling on the object? Well, we still have gravity that's external. Okay, so we still have gravity that's external that's pulling down on the block, which is a part of our system, and so gravity will actually stay out there. Okay, and so if you look at this, now the block plus the incline, we talked about it, and we just said for the block plus the incline, we just said we're still gonna have positive thermal energy, or friction, which was inside. Okay, and now that we have the force, okay, actually don't put the force times the distance. Now that the force times the distance, or the work, comes in, the work will actually cause a change in thermal energy. And remember, the sign is negative because we bring it over, and so this now will become negative delta E chemical. Okay, so that represents our force times the distance, which becomes internal in our system. And now the only thing that left outside is negative mgh. Okay, and so this is a complete circling of all the non-zero terms. And again, if you could get the concept, you draw a picture, look what's inside, look what's outside. Okay, and you could see, once we found the equation for just the block alone, the only thing we did was just add to be internal, subtract to be external. We're just manipulating the same equation going through for all the system. Okay, so I just want you to notice something, that's just what it is. And guys, whenever we talk about only, it could be a block versus a spring or whatever, the only time we talk about one object when there's no potential energy, the general equation is that K final is going to be equal to K initial plus work external plus Q, and then you could fill in any other sources. Okay, so that's the general formula. But again, this is always circling non-zero terms in an energy principle.